Introduction to heat transfer. Heat transfer is thermal energy that is moving or transient due to a presence of a temperature difference. We know that when an object with 100 degrees Celsius is placed near to another object that has a 0 degrees Celsius, the energy will be transferred from the higher temperature to the lower temperature, from the object with 100 degrees Celsius to the object with 0 degrees Celsius. This is done through three different methods. The first one is conduction heat transfer, the second one is convection heat transfer, the third one is radiation heat. Conduction heat transfer happens only in solids or stationary fluids. If we have a plate that is maintained at 100 degrees Celsius on this side and the other side is maintained at 0 degrees Celsius, the heat will be transferred from the surface with 100 degrees Celsius to the surface with 0 degrees Celsius through conduction. Conduction happens at the atomic levels where atoms in the solids can't move, it only vibrates. As we can see in this animation, we have these particles that represent the material is at 100 degrees Celsius and it has a lot of energy, so it vibrates more at more speed than the vibration in the atoms that are at lower degrees Celsius. This makes collisions between these particles, which transfers the energy from the more energetic particle to the less energetic particles. This is the method of conduction. This can be clearly seen in this animation. It is represents the molecules of solids or stationary fluids that can't move, as we will talk later about it. These particles can't move but only vibrates in its place, and when it vibrates it collides with the next layer of molecules. Then it transfer its energy from it to the lower energetic particle and so on till the 0 degrees Celsius gets the energy, and this is the heat transferred represented by these arrow lines. Conduction also happens in stationary fluids. Stationary fluids are present as we can see in our homes in a double glazing window. If we have a double glazing window, you will see that there is a small gap that has an air inside it. This air don't have a lot of space to move, like in the outside atmosphere. So heat will be transferred in this layer through conduction because particles don't have much space to move, as we will discuss in convection heat transfer, which is the main mode of heat transfer in fluids, as we will see later. We have two concepts. We have the heat transfer and the heat transfer per unit area, which is called flux. When we have double dash, we have heat transfer per unit area, which is watt per meter square, while the heat transfer is in watt. If we have this is a wall and this is maintained at a high temperature and this at low temperature, heat will be transferred from the high temperature to the low temperature. As we can see here, heat transfer is directly proportional to the area. Heat transfer is the total heat that passes through this surface. Eh, eh, Whatever this surface has, any surface area, the heat transfer will pass through this whole area. This is the heat transfer. While the heat flux is the heat transfer per unit area. If we have this plane wall, this same plane wall, we will see that the energy that is transferred through only a 1 meter square of this area is called the heat flux, which means that it doesn't depend on area. So we can say that the heat transfer equals to the heat transfer per unit area multiplied by the area in which heat is transferred through it. So this can be done. Another thing that we need to talk about is Qx. Qx, when we say heat transfer, Qx, we can specify for this wall, for example, an x direction. This is the direction of increasing in x, as we see here. This is a coordinate system that we have put in it in this direction because we know the variation is in this direction. We may have a variation in other directions, so we will have x and y, but we will come to this later in that course. So we have specified an x direction and an increasing direction of it. We have a direction for increasing x, which is this direction. Qx will be in this direction from the high temperature to the low temperature. We will we will introduce some sign convention or that we will be using in solving problems in this course. We have Qx means the heat transferred in the direction of increasing x. This is the mean of Qx. If the heat transferred is in the other direction, like we like we see here, sorry about that, like we see here, the heat transferred is moving in the direction of decreasing x, so we will have a Qx negative. So we have a positive and a negative heat transfer. The positive and the negative represents only that if it is in the direction of increasing x as it is Qx, so it is positive. If it is in the direction of lowering x or decreasing x, we see, as we see here, the temperature at x equals 0.1, for example, is very large, is larger than the temperature at 0 degrees at a distance 0 from the origin. So we'll have a negative heat transfer. Conduction heat transfer is represented by this law, which says that Q, the heat transfer, which is in units of watt, equals to negative K area dt by dx. We will discuss each term one by one. dt by dx is called the temperature gradient, and this represents the change in temperature as opposed to the incremental change in the displacement. If we have a cup that is has a large thickness, and we have its temperatures at 100 degrees Celsius and 0 degrees Celsius, we'll see that our slope is very shallow. It is not very steep. While if the cup is of thickness of low thickness and the temperature difference is the same, 100 and 0, we will see that we will uh, we will uh, will we will sense the temperature the heat much larger in our hand if the cup is very thin, while if the cup is very thick, we will see that the temperature is not very high. So the heat transfer depends on the change in temperature divided by the change in displacement. This is one factor. The other factor is area. As we have seen before, the heat transfer increases linearly with the area. If we have a heat transfer through a 1 meter squared, the heat transfer will be doubled if we have a 2 meter squared. The third term in this equation is the K, which is called thermal conductivity. It is a constant that depends only on the material. We know that there are materials that has a high temperature, a high thermal conductivity, like copper, that if you touch a hot copper, get you will sense the more heat than if we have an insulation over the hot surface. If we have an insulation, this insulation has a property of low thermal conductivity. This reduces the heat transfer. We have here a heat transfer that is negative because it is the temperature here is high and the temperature here is low, so the heat transfer will move from high to low, and it is in the negative x direction that we specified. Let's take a look at an example. If we have a plain wall that has a thickness of 10 centimeters and its inner temperature surface is 100 degrees Celsius and the outside surface is 0 degrees Celsius, and we have a thermal conductivity of the material of 1 watt collimeter, 1 watt per meter Kelvin, and an area of 2 meter square. It is asking us to evaluate the heat flux in the x direction and the heat transfer in the x direction. We know that the difference between the heat flux and the heat transfer is multiplying by the area. Heat flux is the same as the heat transfer, but it is for 1 meter square of the area. To solve this problem, we will introduce our equation. The heat flux is negative K dt by dx multiplied by the area, which we set to be 1 meter square because we are measuring the heat flux. So we have a one which don't affect the calculations. We have negative. What is the meaning of the negative? Negative here is present to accommodate for the to uh, to correct the sign. Sorry, I haven't talked about this. If we have a temperature, we have x here is increasing. If the temperature is increasing in x direction, we will have a dt by dx which is positive. The change in temperature divided by the change in x is positive in this case, and we will have a heat transfer from the higher temperature to the lower temperature, which means the heat transfer will be in this direction. So if we have a positive dt by dx, we need a negative qx, a negative heat flux or a negative heat transfer. While if we have a negative temperature gradient, which means the temperature decreases with the distance x, we will have a negative heat transfer. When we have a negative heat transfer, we will have a negative temperature gradient, and we will have a positive heat transfer because it is in the same direction of increasing x. So this is why we have a negative sign. So if we plug in our uh, our variables here, we will have negative k. The thermal conductivity is 1. and dt by dx is the change in temperature divided by the change in x. Temperature at the x equals 0.1 0.1 meter because we use SI units, which is meters in this case. Temperature at the x equals 0.1 meter minus temperature at x equals 0 meter divided by the thickness, which is 10 centimeters or 0.1 meter. Temperature at 0.1 meter is 0 degrees Celsius, and temperature uh, at 0 is 100 degrees Celsius. If we make the calculation, we will get 1,000 watt per meter square. Next, if we need to find the heat transfer, it is the heat flux multiplied by the area. This area is 2, so 1,000 times multiplied by 2 is 2,000.